We just delivered the first crew module to the ONC building at KSE. We've started a lot of the parts onto the outside of the CM, and we've actually put it in what we call the bird cage, so we can locate all those parts within thousandths of an inch to make sure that everything is going together okay.
Putting wiring inside of it, putting tubes for the for the propulsion system, putting valves and pumps, and so all of that happens in stages right there in the ONC building.
We have on contract with USA, United Space Alliance, to build our harnesses. They're set up shop in the ONC, and so their little shop delivers to the big shop.
EFT1 will test some of our high-risk areas, and one of the high-risk areas is the thermal protection system.
So the material's got to be different. It's got to be able to take and withstand this energy.
Thermal protection is very difficult in re-entry vehicles to test and to model. I mean, really you have to fly it to really understand what's going to happen. We're building ceramic thermal insulation tiles for the back shell of the capsule. We're building thermal barriers for the capsule, and we're building multi-layer insulation for that capsule.
I'm the heat shield design lead. So we're designing and building the heat shield for the future Orion missions.
The EFT1 heat shield is unique in the way that we have to machine the entire surface.
The heat shield right now is in our big 20 by 20 router. It's a 5-axis router, and right now it's machining the interior bowl, if you will, of the heat shield.
To cut out that heat shield on the router, it could take weeks of machine time running multiple shifts.
It's the biggest heat shield ever constructed.
The other component is the heat shield skeleton, so that's the piece of the titanium substructure, the backbone that makes up the carrier structure itself.
Another unique thing is all the hand drilling that we're doing. So it's not automated by a router in this case, and it all has to be hand drilled by technicians on the inside.
Yeah, all the pieces come pre-machined, and a lot of pilot holes in it.
200 plus titanium parts, all match drilled together.
So we have a tool that puts all the pieces in the right spot, and then we drill and high lock them all together.
MCC is transforming from supporting Space Shuttle and Space Station to a platform that will support Space Station and MPCB or Orion.
In order to adapt for the future, we need to go to a more modern system.
I'm a flight controller, so I'm helping prepare the ops portion of this flight test. KSC will operate the vehicle all the way up until launch. We'll operate the vehicle until splashdown, and the recovery forces come in and take over after that. This is the test to prepare us for EM1 and EM2 and the execution of those flights. And those flights are what's going to get us back to lunar altitude or beyond. So just this being part of the stepping stone of a huge milestone in a program is exciting.